Hello once again. In the previous video, I discussed about definition of function, definition of relation, and what kind of relations can actually be called as functions. We checked restrictions on domain, and then we tried with some of the functions using Venn diagram to find out whether they are some of the relation we tried out just to see whether they are function or not. Now there is one more method to find out if a graph is given of for any of the function, then we can any of the relation we can find out that whether that graph is actually of a function or not. So we are just going to take a few of the curves. This is called a vertical line test. So I'll just make x and y axis over here. So there is one curve like this, there is one curve over here like this, then there will be one curve like this, then there will be one curve like this, and maybe we can take a cubic function like this. Okay, now vertical line test, what we can do, you just drop vertical or perpendicular on x-axis to check this vertical line test. If what we are going to do, we are going to draw perpendicular on x-axis, and if these perpendiculars meet the curve more than one point, then the curve won't be called a function. Now over here you can see we drop the perpendicular on x-axis, but all these perpendiculars are meeting this function, this curve only at one point, so this will be a function. Now let's try the same test on the another graph. Now I'm plotting perpendicular, I'm drawing perpendicular on x-axis, and you can see these graphs are meeting only at one point. These lines are meeting only at one point, so this is also a function. Now let's take the third one. If I'm dropping a perpendicular on x-axis, the line is intersecting curve at 2 points, so this cannot be a function. The same way over here, if I drop a perpendicular, it's meeting at more than one place, 1, 2, 3, 4 and 5, so again this is not a function. Now if I take the another graph and if I drop a perpendicular like this, you can see this, for this graph, for this curve, perpendicular on x-axis meeting at one point, so this will be called a function. So this is one test, it's called a vertical line test, just to check whether the given curve is a function or not. Now we will discuss in detail about domain of a function, codomain of a function, and range of a function. Now say my function is given to me, that my function is defined from set A to set B. So my set A will be known as domain all the time, or we call it values of x also, values of x domain. Now when I talk about codomain for a function, this is something when all the values, like if function is defined from set A to set B, then all the values which are going to come, or all the members of set B, are part of codomain. So say my set B is ABC, and say my set A is 1, 2, 3. So all these values 1, 2, 3 are in domain and ABC are in codomain. Now if I define a function over here, say I'm just drawing again the Venn diagram form. So I'll just write the elements over here, 1, 2, 3 arrow diagram, and then A, B, C. Say my function is 1 to A, then 2 to B, and 3 to B. Now first thing, I'll just ask myself whether it is a function or not. So what I'll do, I'll just go back to those two criteria. Number one, no element of the domain should be left unassociated. So you can see 1 has image over here, 2 has image as B, 3 has image as B. So no element is left. Now second condition, no element of set A, or means domain, can be associated with more than one element. So if I'm just going to write it like this in the roster form, so I'm just going to write 1 is associated with A, 2 is related to B, and 3 is also related to B. So all the elements of domain taken 1, 2, 3, and no element of set A is associated with more than one element of the codomain. So this is a function. Now range is all the elements. So when I have to write the range, it can be same as codomain and it can be different also. Over here my range is going to be A and B. So codomain was A, B, C. So all the elements of set B, all the elements of set B will form codomain. But all the elements of set B which are actually associated with elements of set A will be called range, or they are going to form range together. So this is what is domain of a function, then codomain and range of function. Now we will actually see some graphs, and then we will try and identify what can be the possible domain and what can be the possible range. So when I say domain of function, so I'll just consider values on x-axis or values of x, and when I talk about range, so basically it is values of y or all the values on the y-axis. So I'm just going to take some of the functions over here. Let's see, we will start with the over here. We are going to start with some of the functions. So just put input y equals to I'll just put some values. Y is equals to say 3x, and I'll just see the graph of it. So y is equal to 3x. You can see that there's a straight line over here for sure. Now you can see all these values on x-axis, all the values of x are going to make domain, and though it's not visible over here, but if I scroll it, if I take it down, then you can just see that values of x are going on the negative side, and then curve is also means extended. So it's not broken anywhere, and you can see if I'm going up and up, I can get corresponding values of y. So for me, domain will be all these values on x-axis, and range is going to be all the values from negative infinite to positive infinite are going to frame my range. So this is y is equal to 3x. This is a linear function. Let's try out some other function, that is say y is equals to x square maybe. So this is y is equal to x square. Now you can see this is also a function. If I'm going to drop a perpendicular on x-axis vertical line test, it is going to meet the curve only at one point. Now when I say about domain, so value of x, so you can just see you can put any value of x, and you're getting corresponding value of y over here. So that means again over here my domain is going to be minus infinite to plus infinite. You can put any value of x over here, but when I talk about range, you can see that curve is not going below x-axis over here. Curve is only above x-axis. That means my domain over here starting from here 0 and is going to the range is starting from 0 over here and is going up to infinite. So my domain will be minus infinite to plus infinite. My range is going to be 0 to infinity. So this is how we identify range and domain. If I have a graph, let's take some other curve. Let's say y is equals to modulus of x mod x. Okay, so maybe I'll just take another curve. Y is equals to x and then Q. And let's see the curve. Curve is something like this. Again, over here you can see that for all the even the negative values of x, we will get some curve over here. If you want, I can just show you like this. For negative values also we are getting some values of x will be there. So you can put any value of x over here. And for y, now when I go y, it's going up to the positive infinity, it's going down to minus infinity. So you can put any value of x. So my domain is going to be R, set of real numbers, or minus infinity to plus infinity, and my range will be also from minus infinity to plus infinity. So this is how we can identify domain and range if graph is given, and domain represents values of x, all the values we are going to take on x-axis, and range will represent all the values of y, values taken on y-axis.